Welcome to Conversations with STEM, the channel that helps you talk and learn with your children about science, technology, engineering, and math. In this video, we're going to walk through how to construct a scientific explanation. I'm sure the first question that many people will have is, what's in the cups? The cup on the left has water in it, and the cup on the right has vinegar. That being said, you don't need to know what's in the cups to have this conversation. The focus on constructing a scientific explanation is to use evidence to support a claim, and explanations can and should change over time as new information is discovered. The focus for this video isn't about getting a right answer in the very beginning. Rather, you should use this video to uncover your child's thinking about the information they're processing. Start by having your child observe the behavior of the liquid in the cups. Ask questions like, what is the liquid doing? What does the liquid look like? What properties of the liquid do you notice? An explanation has to have evidence to support it. Evidence comes from our senses and measurements from scientific instruments. It's the facts we observe. At this point, we don't know a whole lot about this liquid. Your child's observations will probably sound something like this. The liquid is colorless and sloshes around inside the cup. At this point, that's all the information we have, and that's okay. One of the main methods for constructing an explanation is claim evidence reasoning. By labeling and separating out each piece of the explanation, we can better understand what's required for a robust scientific explanation. A claim is something we believe to be true or accurate. The claim in this video is what we believe the liquid in the cup to be. Ask your child what they think the liquid in the cups is. The answer is their claim. If this is a new way of thinking for yourself or your child, the claim can be daunting due to that feeling of, what if I'm wrong? Remember, the goal of an explanation is not to get the correct answer right away. If you find that your child gets stuck at this first step, you can give them what we might call an anti-claim that they can reject. For example, you might ask, do you think the liquid is milk? Next, we need to gather the evidence that supports our claim. At this point, your child will probably only have about two pieces of evidence: that the liquid is colorless and that it sloshes around inside the cup. As long as the evidence supports their claim right now, they have a scientific explanation. They might say the liquid is water, or vinegar, or maybe rubbing alcohol or nail polish remover, and all of these answers would be supported by the evidence we have. Let's go back to that anti-claim we referenced earlier. If you asked whether the liquid is milk, the evidence we've collected doesn't support that claim. Once your child has explained why the liquid could not be milk, you can ask them what they think it might be, and at this point, they should be able to make a better claim. If your child has a claim that's not supported by evidence, you might choose to pause the video and explore that claim. For example, what if your child says, I think there's oil inside the cup? That would be a perfect moment to go to your kitchen and grab a bottle of oil if you have one, and mimic the movements of that cup. The last part of an explanation is the reasoning. Reasoning connects the evidence to the claim. It states why the evidence proves the claim is true. Let's make the claim that the liquid is water. Our evidence is that the liquid is colorless and sloshes around inside the cup. Reasoning shows us why this evidence is important. I could say something like, I know that water is a colorless liquid. Because I know that water is colorless, and I saw that the liquid in the cup was colorless, I think the liquid is water. This is a very formal way of constructing an explanation. Let's take a look at a hypothetical conversation that's a little bit more informal. What do you think is inside the cup? Water. What makes you think it's water? Because it looks like water. What does water look like? It's a liquid you can see through, like I can see through the water in my water bottle. Now we have an explanation. Let's gather some more evidence and see if our explanation still holds true. We're going to add blue food coloring to the liquid. Pause the video and have your child predict what will happen based on their claim. My claim is that the liquid in both cups is water. Therefore, I think the food coloring will mix and make the liquid blue. Watch the food coloring being mixed in and have your child make observations. What happened to the liquid and the food coloring? Was their prediction correct? Again, it's fine if this new evidence contradicts their claim. I want to make it crystal clear that claims can change over time. If their claim is rejected, go through the process of constructing an explanation again. Based on the new evidence, what do they think the liquid is? My claim is that the liquid is water, and the new evidence of the food coloring mixing into the liquid still supports my claim. It's not that I'm right, my claim is being supported. Moving away from the idea of being right or wrong and moving towards evaluating and revising claims over time will increase the idea of collaboration instead of competition. Let's do one final experiment, adding baking soda. Ask your child what they think will happen when baking soda is added to the cups. This is an activity that can derail younger learners, so we really need to focus on the claim. Everyone, myself included, loves a fun scientific explosion. Your child may predict it will explode. Unless they've been saying the liquid is vinegar, this is not a prediction based on their explanation. I found the best way to redirect learners is by asking, is that what you think will happen based on your evidence, or is that what you want to have happen? Since my claim is that the liquid is water, my prediction has to be that the baking soda will just mix in and make the water cloudy. I don't have any evidence that will support an explosion happening. Watch the final experiment and have your child make observations. Now let's revisit our explanation one last time. The cup on the left still matches my claim of the liquid being water, as all the evidence supports that claim. The cup on the right, however, just behaved in a completely different way. At this point, I need to revise my explanation for the cup on the right. Go back to creating an explanation and walk through the steps with your child. Remember that the reasoning needs to connect the evidence to the claim. If your child has more than one piece of evidence, they'll need to explain their reasoning for each piece. A more informal explanation might sound something like this. Do you still think both cups are water? No, the cup on the right had vinegar. What did you see that tells you that? When the baking soda was added, it fizzed and made a ton of bubbles. How does that tell you the liquid was vinegar? It did the same thing as when we made volcanoes and mixed baking soda and vinegar to make them erupt. I hope this video helps you have conversations with your child while constructing explanations. If you want to continue this activity, visit the Conversations with STEM website in the description box below to carry out an investigation with your child that determines what this mystery fizzing liquid could be. Leave a comment down below and tell us how the conversation went, and visit our forum for questions and discussions about scientific conversations. Thanks so much for watching, and we'll see you next week.